to our machine design series. Today we are talking about static failure of fasteners. So we're going to develop 3 different factors of safety to predict the static failure of fasteners. The first one is simply the factor of safety guarding against our stress exceeding the proof strength. Okay, so remember that the proof strength is the strength of the bolt that a manufacturer literally proves that a bolt can withstand without retaining any plastic deformation. It's different from the yield strength. It's lower than the yield strength. And we're taking that proof strength, dividing it by the stress in the bolt, which is equal to the sum of the preload plus the portion of the external load that the bolt takes from the joint, where we know that portion due to our joint constant C. It is common for us to load a bolt pretty close to the proof strength, and so this yield factor of safety is often not much greater than 1. And because of that, we often will use a different factor of safety to indicate yielding, and that one is called the load factor. Okay, so on the left here, I have written out the equation that we use to solve for the load factor. That equation has the same terms as sigma b, except for now we've applied this load factor to our external load. So essentially what this equation is saying is that if we take the portion of the external load that our bolt absorbs, multiply it by some safety factor so that we're increasing it, and add the preload, and then divide that by our tensile stress area, that will be equal to our proof strength. So solving for the load factor, we can get this equation for that safety factor. And notice that it is very similar to the factor of safety guarding against exceeding the proof strength, with the major exception that the preload shows up in the numerator instead of the denominator. Okay, and then the last factor of safety that we're going to use to predict failure of a bolted joint is the joint separation factor. So remember that if we have a bolted joint, and let me quickly draw one. As we apply an external load, tensile load, to this bolted joint, the joint factor C tells us how much of this external load goes to the bolt. But if we ever reach the point where the 2 plates actually separate, then 100% of the external load is going to be taken by the bolt. It's the only thing that's holding the 2 parts together. So we often will think of this condition as a failure condition. And the factor of safety guarding against this type of failure is given by okay, here's our equation. So the factor of safety guarding against joint separation is given by the ratio of the preload to the portion of the external load that is taken by the members. So the preload tells you how much those members are being clamped, and this portion of the external load tells you how much they're being pulled apart, essentially. A couple notes on these factors of safety and the static loading of bolted joints. If we have high quality bolts, we can load them into the plastic range and actually expect to develop more strength that way. So for high strength steel bolts that you're using as structural steel connectors, if you're using advanced tightening methods, you can tighten to yield. So on that note, let's take a look again at the stress strain curve for a typical bolt material. Okay, here's a typical stress strain curve, and notice that there is no clearly defined yield point, that the diagram progresses smoothly up to fracture, which corresponds to the tensile strength of the bolt. This means that no matter how much preload you apply to a bolt, it will retain its load carrying capacity. This is what keeps a bolt tight and determines our joint strength. Now, the amount of preload that you apply to a joint determines the strength that the joint has before any external load is applied. All right, now there are different recommendations for the amount of preload to apply to a bolted joint. Some particular applications we may want to apply all the way up to the proof load. Maybe we want to exceed the proof load. But in general, a reasonable guideline for the preload is to use 75% of the proof load for a non-permanent connection where we want to reuse the fasteners, and to use 90% of the proof load for a permanent connection. Okay, so that covers most of what you need to know about the static loading of joints. We talked about the recommended value of preload for both reused and permanent connections, and then we used that preload in some safety factors that we developed for the static loading of joints. So notice that the higher this preload is, the higher your factor of safety will be guarding against joint separation, which of course has a limit. At some point we will fail the bolt, but in general a higher preload is going to give you a stronger connection. And we also of course talked about the load factor and the factor of safety guarding against yield. So thank you for watching. That wraps it up for this topic. In the next video, we will talk about the fatigue failure of fasteners. And then we will do a review video for the final exam. So stay tuned for that, and I hope to see you in the next one.